Hello KCET 2025 aspirants, welcome back to our channel Diksha Karnataka. So today in this video we are going to solve the part 2 of KCET 2023 chemistry paper, where we'll be solving the next 30 questions, that is from question number 31 to question number 60. So if you haven't watched the part 1 of this video, the link of that video will be there in the description section. You can go and watch the first 30 questions. So yes, now let's get started. One more important information here, the question paper PDF will be available in our WhatsApp channel, and the link of the WhatsApp channel will be there in the description section of this video. Okay, so please go join the WhatsApp channel, download the paper, start solving it, and then come here and see the solutions to know what is your level of preparation right now. Okay, so yes, now let's get started with the first question of today's, that is question number 31. A better reagent to oxidize primary alcohols into aldehydes. So this question is from your, I can say, alcohols chapter also, aldehydes chapter also. The reagent used for primary alcohols to convert it into aldehydes is your PCC. Okay, I think everybody would have known this. If you treat with alkaline KMnO4 CrO3 or acidified K2Cr2O7, then what will happen? The primary alcohol will get converted to acids. Okay, because it is a very strong oxidizing agent, whereas PCC is a mild oxidizing agent. So it will convert the primary alcohols to aldehydes or ketones. Okay, so that is why the correct answer for this question is option number D. I think this question was quite easy and direct, and we just need a fraction of seconds to solve this. Okay, next question, coming to question number 32. The correct order of match between column X and column Y. So here you can see this question is from the chapter biomolecules. Okay, so vitamins and hormones functions are very important. Questions have been asked repeatedly from this section. So yes, please pay attention to this part of this chapter. Now vitamin A is for, if you know, it is for night blindness. So 1 is 3. So 1, 3, we can eliminate option A because it is 1, 2, and we can eliminate option D. Now coming to vitamin D. Vitamin D is related to rickets, right? You remember that it is related to bones, and bones, one of the term is osteomalacia, right? So the correct answer for 2 is 4. So here 2, 4, here 2, 2. So this also eliminates. So correct answer for this question is option number C. Then vitamin E, 3 is what? Muscular weakness, and vitamin K is clotting, blood clotting time. Okay. Okay. Now coming to question number 33 here. In the reaction, so this reaction is given to you, you need to find out P, Q and R, where P, Q, R are the reagents given. So NH2 to convert it to N2 plus and Cl minus. So if you know, this is benzene disonium chloride, and this conversion takes place in the presence of NaNO2 and dilute HCl, right? So this concentrated HCl is there, so we can eliminate this option. Here NaNO3 is there, so we can eliminate this option. NaNO2 and dilute HCl, NaNO2 and dilute HCl. Next you see BF4 minus is coming, right? So this can come if you treat it with HbF4, right? If you treat with HbF4, BF4 minus ions is produced, and that replaces the Cl minus ions. So here the correct answer is this one. Now here Sandmeyer reaction, copper with NaNO2 will get NO2. So the correct answer for this question is option number D. Again, I'll mark this question as an easy question because it is directly reaction based questions. Okay, and all these reactions are there in your NCERT book. Okay, now let us go to question number 34. Thyroxine produced in the thyroid gland is an iodinated derivative of. So this question is again from biomolecules. So yes, so this thyroxine produced in the thyroid gland is an iodinated derivative of tyrosine. Okay, correct answer for this question is option number B. This is theoretical question, you need to learn this data. Okay. Next, coming to question number 35, again the question is from biomolecules. So we have seen this is again a high weightage topic, 3 to 4 questions are asked, and it is a very scoring topic because you do not have any calculations here, you just need to remember some important theories and important concepts. Okay, so yes, this chapter should be a must done chapter for your KCET 2025 examination. Okay, now sucrose is dextrorotatory, but after hydrolysis in the mixture, so levo-rotation, this is because. So when sucrose breaks down, okay, we get glucose and fructose. Okay, so now Sucrose is a non-reducing sugar, that is correct, but that does not affect anything about its levo rotation and dextro rotation. Racemic mixture is formed. If racemic mixture is formed, then the compound will become optically inactive. There is no dextro and levo rotatory now. Now I told you sucrose, okay, sucrose is dextro rotatory, but when you break it, when it undergoes hydrolysis, what we get? We get glucose, okay, and we get fructose, right? Fructose is levorotatory and glucose is dextrorotatory. Now what happens? This levo-rotation of fructose is much higher, so that is why the overall sample or the overall solution becomes levorotatory. So levo-rotation of fructose is more than the dextrorotation of glucose, okay? So that is why this is the correct answer. Now levo-rotation of glucose, this is wrong because glucose undergoes dextrorotation. So that is why the correct answer here is option number C. Okay, easy question again. Easy question. Next question number 36 here. Receptors are proteins and crucial to body communication process. These receptors are embedded in. Again, this question is from biomolecules. Okay. So these are embedded in your cell membranes. Okay. Correct answer is option number D. Again, this is, I'll tell, moderate question because we do not generally pay more attention to such details about these hormones and all where we lack. But yes, it is a direct question, so you need to be little more more precise, and you should read the NCERT books very carefully so that you do not miss out on these type of questions. Okay. Now coming to 37, which of the following monomers form biodegradable polymers? Okay, so this question is from your polymers chapter, but you need not study this chapter because it is from the deleted topic. Okay, so but I'll tell you the answer. Biodegradable polymers will be from 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. Answer is option number C. Okay. Next, coming to 38, again this question is from your polymers chapter where you need to match the options. Okay, so polymers, this question, the answer is option number, okay, caprolactam. This is from this chloroethane is the molecule, is the monomer unit for sorry, one second. Okay, for caprolactam, this part, okay, this is your monomer unit, and then you have for vinyl chloride, this is there. For styrene, we have this one, and for propene, we have this one. Okay, so the correct answer for this question is option number C. Okay, but again, you need not worry this. This is from your deleted portion. Okay. Now let us go to 39th question. Which of the following is a non-narcotic and analgesic? Again, this is also from, I think it is from your chemistry in everyday life. This concept, chemistry in everyday life. Okay, so again, this is your deleted portion. No need to study this. Analgesic, non-narcotic is your aspirin. Okay, but you can see morphine, heroin, these all are narcotic drugs. Okay. Now coming to 40th question, which of the following statement is incorrect? So bond order. Okay, this question has come from your chemical bonding. Okay, PU1 topic, chemical bonding. Okay, now let us check. Here is a very easy trick that you should know how to calculate the bond order. Okay, so if you know the total number of electrons is 14, then bond order is 3. Okay, for 13 it is 2, for 2.5, for 12 it is 2, and for 11 it is 1.5, and for 10 it is 1. Okay, these things you need to know. Next, for 15 it is again 2.5, for 16 it is 2, for 17 it is 1.5, and for 18 it is 1. Okay. Okay, if the total number of valence electrons, sorry, the total number of electrons I am saying, if these values are coming, then the bond orders will be like this. So now if you see O2 plus, okay, let us calculate. O2 plus has how many electrons, tell me? O2 has 8 plus 8, 16, and there is 1 plus charge, means 1 electron will be subtracted, so 15 electrons are there. So for 15 electrons the bond order is 2.5. Now if you see O2 2 minus, right, 8 plus 8, 16 plus 2, again 18 electrons, and for 18 electrons the bond order is 1. So I can say that the bond order of O2 plus is greater than the bond order of O2 2 minus, but the statement given is the opposite. Bond order of O2 plus, that is 2.5 is less than 1. That is what they are saying. So the statement is incorrect. So the correct answer for this question will be option number A. Okay. So again, this is an easy question if you know this trick. If you can calculate the bond order in fraction of seconds, otherwise you can do the molecular orbital theory, draw the diagram and then calculate the bond order, but that will be a lengthy process. But if you know this trick, you can easily solve this question in fraction of seconds. Next, coming to question number 41. A gas at a pressure of 2 atm is heated from 25 degrees Celsius to 323 degrees Celsius and simultaneously compressed to 2/3 of its original volume. Then the final pressure is, okay. So this question can be from your like states of matter chapter, which is a deleted portion, but the gas laws are like the Avogadro's law, some important laws are there in your first chapter also, like Avogadro's law is there. So that is why this question you can like very important gas equation, that is ideal gas equation is used, which is very common. So that is why this question is solvable. Let us try this question. So first one, we need P1 V1 by T1 is equal to P2 V2 by T2. Okay. Now if you see the pressure, P1 is how much? 2 atm. Okay. V1, let it be V. Temperature 25 degrees Celsius, so that is 298 Kelvin. Now I have to calculate P2, and V2 is 2/3 of the initial volume, right? And the temperature here is 323 degrees Celsius. So I will add it. So I'll get 273. So we will get 596, right? So into 596. Now let us try to solve this equation. So now you see we can cancel V, B, 2, 2. Okay. So P2 will be equal to 3 into 596 by 298. So this one will be 2. So I'll get 6 atm. Okay. So the correct answer for this question will be option number A, that is 6 atm. Now coming to question number 42, the lattice enthalpy for NaCl. So this question is from thermodynamics. PU1 topic, lattice enthalpy of NaCl is 788 kilojoule per mole and the hydration enthalpy is minus 784 kilojoule per mole. Enthalpy of solution of NaCl. Okay. So here you need to know the formula that delta H of solution is equal to delta H lattice enthalpy plus delta H hydration. Okay. So now very simple, let us put the values here. Enthalpy, lattice enthalpy is 788 and hydration is minus 784. So if I solve this, I'll get 4 kilojoule per mole, right? So the correct answer for this question will be option number A. Again, this question is very easy if you know this formula, okay? But again, the trick or the catch that lies here is this formula comes towards the end of the chapter in the what we call summation. Okay, there this part is there and this formula is not very important formula for thermodynamics, but yes, if you know this formula, it is again a very easy question. Just you need to subtract two numbers. Okay, now let us go to 43 question. At 500 Kelvin for a reversible process, A2 plus B2 gives 2AB in a closed container. Kc is given, so equilibrium constant. So we have reached to the concept of equilibrium chapter now. Okay, PU1 again. So you see from PU1 very 1-2 questions are asked, but you remember in PU2 chapters the questions asked from each chapters are 3-4 questions are asked, right? So that is why for your KCET exam PU2 is very important and you need to master them really well. Okay. Okay, now let us do, in the presence of catalyst, the equilibrium constant is attaining 10 times faster. The equilibrium constant Kc in the presence of the catalyst at the same temperature. This question is super easy question, I'll tell. But at the same time, it is damn tricky question. You need to understand that with by using the catalyst, equilibrium can be reached faster, but equilibrium constant still remains the same, right? So that is why this was a question to trick you, but those students who have understood the concept correctly, the fundamentals are strong, they will not do mistake in this question. So whether it is, whether you use catalyst, whether you do not use catalyst, whether the temperature, like you do not use any catalyst, still the equilibrium constant will remain same. Catalyst does not alter the equilibrium constant. So still after adding catalyst also, your equilibrium constant will be 2 into 10 to the power of minus 5. So the question, the correct answer for this is option number C. Okay. Now coming to question number 44, a weak acid with weak acid, strong acid, if you remember, this question is also from equilibrium, but now it is ionic equilibrium. Okay, a weak acid with pKa 5.9 and weak base with pKb 5.8 are mixed in equal proportions, pH of the resulting solution. Okay, so if you remember, for pH of salt hydrolysis, pH of weak acid plus weak base is equal to 7 plus half into pKa minus half into pKb. So if I substitute here 7 plus half into pKa value is 5.9, okay, and we have pKb value is 5.8, okay. So if you solve this, I'll be getting around 7.05, okay. So the correct answer for this question is option number C, okay. Now let us move to the next question, 45. Temperature of 25 degrees Celsius in Fahrenheit and Kelvin scale respectively are. So this question is from your first chapter, that is some basic concepts, where we studied about the fundamental quantities and their conversions, their significant figures, right? We generally ignore them, but yes, questions have been asked from that portion also. Now temperature of 25 degrees Celsius in Fahrenheit scale. So if you know, to Celsius to Fahrenheit, if you want to convert, so Celsius into 9 by 5 plus 32 will be your in degree Fahrenheit, right? So let us do this one. So I have 25 degrees Celsius into 9 by 5, so plus 32, right? So 45 plus 32, it will be 77 degree Fahrenheit, right? So you can see only one option is having 77 degree Fahrenheit, so answer has to be option number D. But again we'll check this one. Kelvin, 25 for Kelvin we need to add 273.15, right? So it will get 298.15. So the correct answer for this question is option number D. Okay, again this is very easy question if you haven't ignored this formula. See, you might have remembered this formula because in many numericals we solve Kelvin to, we convert Celsius to Kelvin, but that is why also you see there are two options with 298.15. So the examiner also knows that you know this formula, but he also knows that you might not be knowing this formula. So that is a very trickily the options are given to you. But yes, if you have studied the first chapter, if you know this formula, then again a super easy question. Now let us go to 46th question here. The number of protons, neutrons and electrons in the ion given are. Again this is very easy question. You have S, 16, 32 and 2 minus, right? So this represents Z, the atomic number, that is the number of protons. So I'll write protons is equal to 16. And this one is the total, that is proton plus neutron is 32. And we came to know that proton is 16. So neutron will also be 16 here. Now electrons, if you see, the number of protons and electrons are same in a neutral atom, but here 2 minus charge is there, so the total number of electrons is 16 plus 2, that is 18. So the correct answer for this question will be 16, 16, 18, that is option number A. Again this question is also easy one, okay. Next, coming to question number 47, the correct order of first ionization enthalpy of given elements is. So this question is from your periodic classification, right? So you need to know little like the exceptions that you have to remember in this particular chapter. So first ionization enthalpy, if you see the options given are lithium, beryllium, boron and carbon, right? So if you remember, these four elements belong to the same period, and along the period what happens to the ionization enthalpy? Along the period the size decreases, right? Size decreases, so that is becomes difficult to remove the electron, so ionization enthalpy increases, right? So along the period ionization enthalpy will increase, but ionization enthalpy depends on many factors, and one of the important factor is the electronic configuration of the atom. So let us see the electronic configuration for this one. So lithium atomic number is 3, so 1s2, 2s1, then beryllium is 1s2, 2s2, boron is 1s2, 2s2 and 2p1, and carbon is 1s2, 2s2 and 2p2. Now if you see here, if your expected order should be along the period because size is decreasing, so lithium, then beryllium and then boron and then carbon, right? But what happens here is beryllium, if you see, it has a fully filled electronic configuration, right? So that is why removing electron from beryllium will be little difficult, because the orbitals are fully filled and very stable electronic configuration. So that is why here we find a small change in the trend, and we see that boron ionization enthalpy is little less than beryllium. The reason is the electronic configuration, the stable electronic configuration of beryllium. Okay, so what will happen, the actual order: lithium, boron, beryllium, and then carbon. Okay, so the correct answer for this question will be option number D. Okay, now coming to question number 48, the composition of water gas. All of you might be knowing that water gas composition is carbon and hydrogen. So correct, carbon monoxide and hydrogen gas. Correct answer is option number C. Now coming to question number 49, the IUPAC name of the compound is, okay, so compound here is not given. I'll draw the compound. The compound was like this. Okay, one second. Okay, let me draw the compound that was given in the question paper. It was like this. Okay, so now if you see here, this is first carbon, second carbon, third carbon, and fourth carbon. On second and third carbon we have methyl groups, so the name will be 2,3-dimethyl. Okay, and then butene, but here we also need to mention the position where the double bond is present. So that is on the second carbon, so it will be but2ene. So the correct answer for this question will be 2,3-dimethyl but2ene. Okay, option number D. Now coming to the 50th question, the set which represents the aromatic species is, okay, so let us see the aromatic species here. So you can see this is a benzene ring, this is aromatic, this is also, there is conjugation, and there is 1 2 3 4 5, 4n plus 2 electrons, 10 electrons are there, conjugation is there, cyclic compounds is there. So yes, this is also aromatic. Now here if you see, this is sp3 carbon, it is not a planar molecule, right? So this cannot be aromatic. Here if you see 1 2 3 4 5 6, again this is aromatic. Okay, and there is also conjugation, so yes, this is aromatic here. Next if you see this compound 1 2 3 4, there are 8 electrons, right? 8 electrons, and because of that what happens, okay, so 8 electrons are there, so it has your anti-aromatic properties, right? So that is why this one is not aromatic. So we have the correct answer as 1 2 and 4. Okay, so the correct option here is option number C, that is 1 2 and 4. Okay, so here the option D option is like 1 2 and 3. Okay, little typing error is here. 1 2 and 4 are aromatic, so correct answer is option number C. Now coming to 51st question here, which one of the following gases converts hemoglobin to carboxyhemoglobin? So again, this is very general question. Carboxyhemoglobin is produced or is converted when the hemoglobin absorb carbon monoxide gases, right? So that is why that is due to the presence of carbon monoxide, option number D. Again, a very easy question and a general knowledge question. Next, what is the oxidation number of S in H2SO8? So again, this is from your P block, group 16. So this is from the deleted topics. You need not study this topic, but again I'll tell you the answer. So this is like this. The structure for this compound is H2S2O8. Okay, OH, sorry, right? This is the compound. Now you see here it is an peroxy linkage is there. So for the sulfur I can have 2 hydrogens as +2. Okay, and let us take 2x as this one, and you see 1 2 3 4 5 6 oxygens, charge is -2, so that is 6 into -2, but 2 oxygen peroxide linkage is there, so charge is -1, 2 into -1. Okay, this is equal to 0. So now if you see 2 plus 2x minus 12 minus 2 is equal to 0, so 2x is equal to, you have 12 and x is equal to 6. So the correct answer for this question is option number C, that is +6. If you calculate without knowing that this is peroxy linkage, then you will be getting +7 as the answer, okay, which is incorrect. Okay, now coming to question number 53, a 30% solution of hydrogen peroxide is, okay, this is again a very important question here. 30% solution of hydrogen peroxide is. Now what is this volume? Okay, so remember, if the amount of oxygen, see, amount of oxygen produced by 1 ml or 1 liter of H2O2 solution. Okay, suppose from 1 ml of H2O2 solution 10 ml of oxygen is produced, then the volume we can call it as 10 volume. If 100 volume is produced, 100 volume. If 100 ml of O2 is produced, then we'll call it 100 volume H2O2. Okay, I hope this is clear. Now this question is little tricky one. So let us 30% is there. 30% solution means 30 gram of H2O2 in 100 ml of solution. Okay, 100 gram actually, but if I consider the density of water is 1 gram per ml, so I can write it as 100 ml of solution. So what I can say that in this 100 ml of solution, how much H2O2 is present? 30 gram. But we need either 1 ml from 1 ml solution or from 1 liter of the solution, right? So if I say that 1 liter means 1000 ml, right? In 1000 ml, what will be the amount of H2O2 present? So we are multiplying 10, so that is 300 gram of H2O2. So we need to calculate from 300 gram of H2O2 how much O2 is produced. So for that we need to know the reaction for this one. So the reaction is 2H2O gives 2H2O plus O2. Okay. Now if you calculate, 2H2O2. Now if you calculate the oxidation state 16 to the 30, the molecular mass, it is 68 gram. So I can say from 68 gram of H2O2, I am getting 1 mole of O2, right? From 1 gram, how much I'll get? 1 by 68 mole, right? And then from 300 gram, okay, I'll get 1 by 68 into 300 moles, right? But we need to calculate the volume of oxygen produced. So to converting the volume to converting moles to volume, you need to multiply it with 22.4. So now if I multiply this with 22.4, I'll be getting around 98.8, which is approximately equal to 100. So I can say that from 1 liter solution of H2O2 solution, 1 liter of H2O2 solution is containing 300 gram of H2O2. So from this 300 gram of H2O2, the amount of oxygen produced is around 100 liters. Okay, so that is 100 volume. So the correct answer for this question is option number C. Okay. Now coming to question number 54, a pair of amphoteric oxides here. So this question is again from your PE block elements. So but this is you need to know that beryllium oxide and zinc oxide are amphoteric in nature. Okay, option number C, again a theoretical question, little difficult. By seeing the options you may not know all about the properties of all the oxides here, but you can know these are metallic, magnesium is metallic, boron is metallic, so they will be basic oxides. Lithium is metallic, so that can be also a basic oxides. So in this way you can eliminate the options and find the answer. Now coming to 55, dimerization of solute molecules in low dielectric constant is due to. Dimerization means when the two particles, when like suppose you are adding two different molecules, but after going into the solution they form one molecule. Okay, so that happens due to the presence of hydrogen bonding. Okay, correct answer for this question is option number D. Now coming to 56, the swelling in the feet and ankles of an aged person due to the sitting continuously for long hours during travel is reduced by soaking the feet in warm salt water. This is because of osmosis, right? So when the osmosis we do, the water gets released from the legs, from your swollen feet, and you feel relief about it. So this question is from your solutions chapter, again an important chapter and a high weightage topic. Now let us solve the next question, that is 57. A sample of water is found to contain 5.85% of AB, molecular mass is 58.5, and 9.5% XY2, molecular mass is 95. Okay, let's stop here and understand the question till now. So there is a sample of water and there are two solutes in that. One is AB, whose percentage is like 5.85, means that for every 100 gram you have added 5.85 gram of this one, and the another solute is XY2, which is added in 9.5%. Their molecular masses are also given to you. Now if you remember, when a solvent is there and if you add a solute, a non-volatile solute, the freezing point decreases, right? This is called as depression in freezing point colligative property, right? So obviously when you add AB and XY2 to a water solvent, the freezing point will decrease, right? So now the question is that AB is not dissociating completely, it is dissociating 80%, and XY2 is dissociating only 60%, right? The freezing point of the water sample is, so we need to calculate the freezing point, the depressed or the decreased freezing point of water, okay? So this question, I'll be putting it in the category of hard question. The reason here is this type of numericals are not there in the NCERT questions, like NCERT books, such numericals are not asked. We generally do which type of questions, if you know, where only one solute is added, right? For that we have a very simple formula, that is delta TF is equal to I into KF into M, right? This is a very simple formula that we have for when one solute is added, where M is the molality, I is the Van 't Hoff factor, and KF is the depression in freezing point constant, right? But when two different solutes are added, how to calculate, such type of questions are not there in NCERT, okay? So that is why I'll tell you the formula for that. If two solutes are added, delta TF is equal to KF I1 M1 plus I2 M2, okay? I1 is the Van 't Hoff factor for the first one, and I2 is the Van 't Hoff factor for the second solute. M1 and M2 are the molalities, okay? So now let us do this question. First, let us see, we have that for AB, okay? For AB, what all the datas we have? It is 5.85%, means this is the given mass, 5.85 gram is present in 100 gram of the solution. So that means 5.85 gram of AB is present, and its molar mass is 58.5. So can I calculate number of moles of AB? So 5.85 divided by 58.5, so that is equal to 0.1, okay? Now if I see that for this AB, the alpha value given to me is 80%, right? 80% means 0.8, so I can calculate I value. So alpha AB is equal to I minus 1 by N minus 1 for dissociation, you know, remember this formula. So now if I substitute, alpha is 0.8, I minus 1, 2 minus 1, so I'll get I is equal to 1.8, okay? This data I have calculated, so let me note down this data and clear this area for calculation of XY2, okay? So I got the I value as 1.8, okay? So let us solve this now. We have for this one I value as 1.8. Now let us solve the next solute, that is for XY2. So for XY2, okay, N value, number of moles, again this is 9.5%, means 95 gram is present, molecular mass is 95, so I'll get 9.5 by 95, that is again 0.1 mole is present, that is done. Now let us calculate alpha, here is given to you 80%, so 0.8, so I'll get 0.8 is equal to I minus 1 by 3 minus 1. Why 3? Because XY2 will give you 3 ions, 1 X plus and 2 Y minus, right? So N minus 1. So I'll get this one 1, so I'll get as 0.8 is equal to I minus 1 by 2. So if I multiply, this is becoming 1.6, 1.6 plus 1, 2.6, I'll get I value. Okay, so let us write down this value here. So for XY2, okay, so okay, let me note down this value now. So for XY2, the I value I got is 2.6, okay. M1 number of moles in 1000 solutions, so we will get an M1 and M2 as 0.1, 0.1. So now let us substitute the values here. So delta TF, so I can calculate 273 minus TF, okay, is equal to KF is around 1.86 something, yes, KF is 1.86, I1 is 1.8 into 0.1, I1 M1 plus, okay, we have 2.6 into 0.1, okay. So now if I have to solve this equation and find the value of TF, okay, now the calculation part is yours. So if you solve this, we'll get the temperature as 264.25. So the correct answer for this question is option number D. So I want all of you to see this, calculate this answer and comment down whether you are getting the correct answer or not. Okay. Now coming to question number 58, match the following. So this question is from your solids chapter. So this is again solids chapter, deleted portion. Okay. So what I will be telling you the answer. Molecular solid is water. Ionic solid is your magnesium oxide. So P is 3. So P3 we have 2 options, and ionic solid Q and 4. So we have only 2 options. Correct answer is option number C. Okay. Now coming to question number 59. Again this question is from your solids chapter, which is deleted portion. So no need to study this chapter. A metal crystallizes in a BCC cubic lattice with a metallic radius given √3 angstrom. The volume of the unit cell is. Okay. So this I will just tell you how to calculate. So if you know that for BCC, what is the relation? 4A is equal to √3R. Okay. So now they have told you that, so what is the value of A? A value is √3 by 4 into R, right? So we need, and the radius value is again √3. One second, one small error here is there. I wrote the wrong relation. One second. So this one is 4R. For BCC, the relation between radius and the side of the cube is 4R is equal to √3A. Okay. So now what I can write? A will be equal to 4 by √3 into R, and R value is √3 given. So I can write A is equal to 4, and the unit is 4 into 10 to the power of minus 10 angstrom. That is it. So I convert it into 10 to the power of minus 10 meters. Okay, because it is asked in the meter units. So now if you take volume, volume will be what? The formula for the unit cell, A cube. Volume of a cube is A cube. So we have to take 4 into 10 to the power of minus 10, the whole cube. So 64 into 10 to the power of minus 30. Now I can write it as 6.4 into 10 to the power of minus 29. Okay, correct answer for this question is option number B. This was again a very easy question, but it is from the deleted portion. No need to study this chapter. Coming to question number 60. If A stands for the edge length of the cubic system, the ratio of the radii. Again this chapter, this question is from your solids chapter, deleted portion. Okay, I'll tell you simple cubic, ratio BCC and ratio FCC. Okay, the radius ratio. For simple cubic, the ratio, like the radius is A by 2. For BCC, it is √3 by 4A, and for this is, it is 1 by 2 √2. Okay. So the correct answer for this question is option number A. Again, this is deleted portion. You need not study this chapter. Okay. So students, we have completed this KCET 2023 paper discussion. If you have any doubt in particular question, please comment down. I'll definitely clear your doubts. And we have already solved KCET 2024 question in our channel, question paper in our channel. If you want to watch those videos also, I'll be providing the link of those videos in our description section. You can go and watch and check your level of preparation. Okay. So yes, please join the WhatsApp channel and download the question paper and start solving it, and then check the solutions here. Okay, and all the very best. Thank you for watching, and please subscribe the channel for more updates.